Hello, Eric. We're just waiting a few minutes till everybody else gets here. Hello, everyone. All right, did anybody have any questions for us to get started with today? Okay, then we're gonna go ahead and get started. Are you guys able to see the screen over here? So right now it's got the law of sines up. Okay, so yesterday we went over section 4.2, which was solving right triangles. And then we looked at section 4.4, the law of sines. And so I thought today we would get going on section 4.5, the law of cosines. Okay, so these are the 4 different cases. And in section 4.4, we looked at the first 2 cases. And now in section 4.5, we're going to look at case 3 and case 4. So we've got kind of our arbitrary generic triangle here, where we have side A across from angle A, side B across from angle B, and side C across from angle C. And so the first thing we're going to do is draw a perpendicular line down from C. So this should say from C. The length of that line will be H. And the bottom side of this triangle has a length of C, but we're going to break it up into 2 right triangles. And one right triangle will have a side that has a length of X, and the other right triangle will have a side with a length of C minus X. And then we can use the Pythagorean Theorem and see that x squared plus h squared, remember this has a length of h, x squared plus h squared will equal b squared, and c minus x squared plus h squared will equal a squared. And what we can do is we can solve each of those. We can solve each one of those for h. And if we do that, we will have h squared is equal to b squared minus x squared for the first one. And for the second one, we'll get a squared minus, buddy, I'm teaching class right now, a squared minus c minus x squared. And if we go ahead and we expand c minus x squared, we get a squared minus c squared minus 2cx plus x squared. So I've gone ahead and multiplied out the c minus x squared. Since both expressions are equal to h squared, they have to be equal to each other. So that's going to give us b squared minus x squared will be equal to a squared. I'm going to go ahead and get rid of the parentheses. Sorry, that should say a squared. And I'm going to get rid of the parentheses, so I have minus c squared plus 2cx minus x squared. And next, what I'm going to do is I'm going to add x squared to both sides. And so we get b squared is equal to a squared minus c squared plus 2cx. And if I solve this, sorry, I just noticed that somebody had made a comment, so I'm just trying to see what that comment was. Oh, so let's see. Should it be a minus 2cx and a plus? Okay. So right here, okay, notice right here, does this part look okay to everybody? So if I get rid of my parentheses up here, I have a squared minus c squared, and then I have a plus 2cx, and then a minus x squared, right? If I get rid of my parentheses, so I think everything is okay. Oh, so here there shouldn't be an S, there would be an X. Okay, thank you. So now solving for a squared, we get b squared plus c squared minus 2cx. Okay, now I want to think a little bit about, sorry, I should say that's equal to a squared. But now let's think about our triangle up here. We know that the cosine of angle A, the cosine of angle A is equal to the side adjacent over the hypotenuse. And the side adjacent is x, and the hypotenuse is b. So that tells me that the cosine of angle A is equal to x over b. So I can solve this for x. We know that x is equal to b times the cosine of angle A. So now I'm going to come back and replace this x right here with b times the cosine of angle A. That's going to give us b squared plus c squared minus 2c times b cosine A equals a squared. Okay, now there was nothing very special about the fact that we chose to put the perpendicular line going through angle C. We could have made the perpendicular line go through angle A, or the perpendicular line go through angle B. Any one of those would have worked. And so if we had done it differently, we would have ended up with one of the other variations. We did a squared, and we got that it was equal to b squared plus c squared minus 2. Notice I flipped the b and the c around, but that's okay. It doesn't matter what order you multiply in. Minus 2bc cosine A. We also get that b squared is equal to a squared plus c squared minus 2ac cosine b, or c squared is equal to a squared plus b squared minus 2ab cosine c. Okay, so those are called the law of cosines. Any questions so far? Okay, so we're going to look at a few examples. We're going to start with thinking about a triangle where angle A is 60 degrees and side B is 20 and side C is 30. So we're going to start with using this first variation of the law of cosines that says a squared equals. So a squared equals b squared plus c squared minus 2bc times the cosine of angle A. So that gives me a squared equals 20 squared plus 30 squared minus 2 times 20 times 30 times the cosine of 60 degrees. And that gives me that a squared is equal to 400 plus 900 minus 1200. And the 1200 is from the 2 times the 20 times the 30. And I'll multiply that by the cosine of 60 degrees, which is a half. And so that gives me a squared is equal to 700. And since A is the side of a triangle, I know A has to be positive. So A will be the square root of 100. I'm sorry, square root of 700, which is about 26.5. Okay. All right, so now we know what A is. We still need to figure out the angles. And the way to find the angles is to actually use the law of sines. So even though that was from the last section, we're still going to be using that. And remember, the law of sines said that the sine of angle A divided by side A equals sine of angle B divided by side B. We know that angle A is 60, so we have the sine of 60 degrees divided by, I'm going to write side A as the square root of 700, and that'll equal the sine of angle B, and we know that side B was 20. So I'm going to multiply both sides by 20. I have 20 times the sine of 60 degrees divided by the square root of 700 is equal to the sine of angle B. And now what I'm going to do is I'm going to go ahead and check with my calculator to see what that's going to give me. So I'm going to do 20 times the sine of 60 degrees divided by the square root of 700. And that tells me that sine of angle B is going to be about 0.65. And then to figure out what angle B is, I'll do the inverse sine. So I'm going to do inverse sine of that number. And that tells me that angle B is close to, I'll go ahead and round it to 41 degrees. Okay, so we found that sine of angle B was about 0.6547. And then to get B, we did inverse sine of that 0.6547, and that came out to be about 41 degrees. And that was rounded. Next, we're going to figure out angle C, and angle C is the easy one. We know that all three angles need to add up to 180 degrees. We know that A was 60, and angle B, we rounded to 41. So we just do 180 minus 60 minus 41, and that gives us 79 degrees. Did anybody have any questions on that one? Okay. For the next one, this time we don't know any of the angles. All we know are the sides. And when we know the sides, you always start with the biggest angle. Okay, so it might seem like we have three options here. But since side B is biggest, that tells us that angle B will be biggest. So we're going to use the middle option where B squared is equal to A squared plus C squared minus 2AC cosine B. I'll go ahead and write that down. B squared is equal to A squared plus C squared minus 2AC times the cosine of angle B. B squared, well, we're going to do 9 squared equals 6 squared plus 4 squared minus 2 times 6 times 4 times the cosine of angle B. So let's simplify that a little bit. We have 81 equals 36 plus 16 minus 2 times 6 is 12. 12 times 4 is 48. So 48 times the cosine of angle B. So we have, if we subtract the 36 and the 16 away from both sides, we get 29 equals negative 48 times the cosine of angle B. And then we can divide both sides by that negative 48. So we have negative 29/48 is equal to the cosine of angle B. So to find angle B, we're going to do inverse cosine. Of the negative 29/48. We're going to do inverse cosine of negative 29/48. And that tells me that angle B is about 127 degrees. Next, I would need to find one of the other angles. It doesn't matter which angle you do next. And to find the other angles, we would use the law of sines. So let's do sine of A divided by A equals sine of B divided by B. So we have sine of angle A divided by 6 equals the sine of 127 divided by 9. And I just want to make sure that it's clear that it's the entire thing here that's being divided by 9, not just the 127. If I multiply both sides by 6, I have that the sine of A is equal to 6 times the sine of 127 divided by 9. And so then A will equal the inverse sine of this number, 6 times the sine of 127 divided by 9. So now let's see what we get for that. So, whoops, didn't mean to make it quite so big. We're going to do 6 times the sine of 127 divided by 9. And that gives me about 0.53. And now I want to do the inverse sine of that value. And that tells me that angle A is about 32 degrees. Can I simplify it before I do my inverse sine? I did simplify it before I did my inverse sine. Is that what you were asking about? Like I punched it in first? So here, I worked it out, and then I did my inverse sine, just to not have to go back and forth quite so much. But I could do it all at once. I could do the inverse sine of 6 times the sine of 127 divided by 9 all at once. And it would come out to be the same thing. Okay, are we all done? Is there anything else we need to do? Well, what we need to do last is figure out angle C. And we know 2 of the angles, so we can subtract from 180. We know angle B is 127 and angle A is 32. And so we end up with angle C is 21. Okay. So next, we want to look at finding the area of a triangle. So if we know 2 of the sides and the angle in between them. Okay, so in general, we know that the area of a triangle is 1/2 times the base times the height. Okay, so let's go ahead and say this is our height right here. We also know that sine A is equal to the side opposite divided by the hypotenuse, which in this case, sine A would be H divided by C. Okay, because we have this right angle in the picture with this right angle. So the sine of angle A is the side opposite, which is H, divided by the hypotenuse, which is C. And now if we solve this equation for h, we get that h is c times the sine of angle A. And so we can replace this h up here with what we know h is equal to. It's equal to c times the sine of angle A. So we're going to get that the area of the triangle is 1/2 times b times, instead of saying times h, I can say times c times the sine of angle A. So that's one way to find the area of a triangle. Okay, well, that was assuming that we knew the angle A and we knew two sides next to A. We knew side B and we knew side C. So we are going to get two other similar formulas if instead of knowing angle A, we were to know angle B and then the two sides next to it, side C and side A, or if we knew side C and we knew the two sides next to it. So we're going to come up with three different formulas, but they're very similar to what we had previously. So we would have 1/2 times b times c times the sine of angle A, if we know B, C, and A, or if we know A and B and angle C, we'll do 1/2 times A times B times the sine of angle C. Or if we know AC and angle B, it'll just be 1/2 times A times C times the sine of angle B. Does that make sense? Okay. So next, we're going to look at an example. It says find the area of the triangle where we know angle A is 130 degrees. And we know side B is 8 centimeters, and we know side C is 13 centimeters. So we'll just plug everything into the formula. We get the area is equal to 1/2 times, and we'll do B times C, so 8 centimeters times 13 centimeters times the sine of 130 degrees. So let's see what we get. So 1/2 times 8 times 13 times the sine of 130. And that gives us about 39.83. Okay, so that was finding the area when we know two sides and an angle. Next, there's something called Hero's formula or Huron's formula. And I'm not going to go through the proof of that. There are a couple of YouTube videos, well, actually Khan Academy videos that you can watch. And then here is the formula. So if the three sides are known, first you would find S, the semi-perimeter, which means you add up the three sides and divide by 2. And once you've done that, the area is equal to the square root of S times S minus A times S minus B times S minus C. So that's one example where the three sides are 80, 75, and 160. So the first thing I'm going to do is figure out what S is. So that's A plus B plus C divided by 2, which is going to give me 80 plus 75 plus 160 divided by 2. And I think, well, what does that give me here? Oh, you know what? I didn't want to use those numbers. I wanted to change those numbers. So let me go ahead and change those numbers. And the reason I changed them is because this doesn't work. So these numbers don't work. So I've changed A to be 6, B is 10, and C is 9. Okay, so those are the numbers that we're going to use. A is 6, B is 10, and C is 9. The numbers that were given there don't actually form a triangle. So I went with numbers that did form a triangle. Plus 10 plus 9 divided by 2. 6 plus 10 plus 9 is 25. So we have 25 divided by 2, and that makes 12.5. So then the area is equal to the square root of 12.5 times 12.5 minus 6 times 12.5 minus 10 times 12.5 minus 9. So let's see what we get for that. So we're going to do 12.5 times 12.5 minus 6 times, I know 12.5 minus 10 is just 2.5, and then 12.5 minus 9 is 3.5. So I'm going to be doing the square root of 710-ish. So the square root of that answer. And that comes out to be close to 26.66. Did anybody have any questions? Okay, so if you don't have any questions on section 4.5, we're going to take a quick look at the next section. The next section is section 6.1, and it's about verifying trigonometric identities. So in math, an identity is an equation that is true for all values of the variable for which the expressions in the equation are defined. If an equation is true, should be a T here, if an equation is true for only some values of the variable, it is called a conditional equation. We already know a whole bunch of identities. So we know the reciprocal identities. We know that cosecant x is equal to 1 over sine x, and sine x is equal to 1 over cosecant x. And we know secant x is equal to 1 over cosine, and cosine x is equal to 1 over secant x. We know that cotangent x is equal to 1 over tangent x, and that tangent x is equal to 1 over cotangent x. And of course, we're not allowed to divide by 0, so there are some restrictions. We also know the quotient identities. We know that tangent x is equal to sine x over cosine x. And we know that cotangent x is equal to cosine x over sine x. And again, we can't divide anything by 0. We also have seen the Pythagorean identities. The one that's easiest for most people to remember is that sine squared x plus cosine squared x is equal to 1. But we've also saw that if we divide through by sine squared, we will get, if we divide through by cosine squared, we will get that tangent squared x plus 1 is equal to secant squared. And if we start with this original Pythagorean identity and we divide through by sine squared, we'll get 1 plus cotangent squared x is equal to cosecant squared x. Okay, and we know things about the functions being even and odd. We know that the sine of negative x is equal to minus the sine of x, and so on and so forth. No, you are not going to need to memorize these for the test. Good question. Any other questions? Okay. Got a few more identities called the cofunction identities, that sine of theta is equal to 90, or cosine of 90 minus theta, and so on. Okay, one of the first things we're going to be looking at is simplifying some expressions. So we're going to start with simplifying sine x plus the cotangent of x times the cosecant of x. So I'm going to leave the sine x alone. I'm going to replace cotangent x with what I know cotangent's equal to. So I know that cotangent is equal to cosine x divided by sine x. I'm going to take that, I'm going to multiply that by cosine x. So now what does that give me? If I simplify, I still have that sine x out in front, and I can think of cosine x as being cosine x over 1, if that helps. I'm going to end up with cosine squared of x divided by the sine of x. Does that make sense to people? Next, I can think about getting a common denominator. If I get a common denominator, that means I'll have both fractions having sine x on the bottom. So my first fraction, I need to multiply the top and the bottom by sine x. So that's going to give me sine squared of x divided by sine of x. And then my second piece is still going to be cosine squared of x divided by sine x. Okay, so now, since the two fractions have a common denominator, I can write it as a single fraction. So I have sine squared of x plus cosine squared of x on the top, and then on the bottom I have sine of x. But now think about the top of this. The top of it is sine squared x plus cosine squared x. What do we know about sine squared x plus cosine squared x? We know that's equal to 1. So we have 1 over sine x. And we could write that as cosecant x. Does that make sense? I'm going to go ahead and see if we can do the next example. The next example is simplifying sine x times cosine squared x minus sine squared x. So I notice that I have two pieces that both have a sine x in them. So one thing I can do is factor out sine x. So I'll factor out sine x, and then in parentheses, I'll have cosine squared x minus 1. So we factored out sine x. And now what I'm going to do is I'm going to factor out a negative 1. And if I factor out a -1, that'll give me 1 minus cosine squared of x.